is Tuesday, May 19th. It's still, of course, it's still Monday, May 18th for people in the United States. And this is the Antrea community meeting. In today's agenda, we will provide an update on cluster network policies. And then we will discuss the trace flow design. Let me just give me a second to see if there are any other proposed topics for today. No, not really. So that's pretty much it. And I guess that for the update on cluster network policy, Abhishek, I guess that will be up to you. Is that correct?
Yes, I can provide a brief update. I think there were a few open questions on the document and on the couple of PRs that have been posted for this. So I thought it's probably a good time to update the changes that we made on the spec, slight changes. Initially, there were a couple of things. The first thing was around category or tiers. The initial proposal, what we said was that the Kubernetes network policies will always be created at the bottom, and the categories will always be created, above those policies, and then the users will be able to create cluster policies and set them to categories, which would always be above the network policies. So I think Cody had a requirement, which he mentioned that we should have the network policies, the Kubernetes network policies, also set in a category, which will be at the bottom. So, instead of just saying that they are outside of categories, they will also be part of the categories, and the category would be the default category, which should always be at the bottom. And then users can also create cluster policies and set the category as the default. So they will be grouped with the same category as the Kubernetes network policy. The other thing was that we should also allow some way or fashion to create cluster policies or namespaced Antrea network policies to be created below the Kubernetes network policies in the same default tier. So that was one thing that we are going to consider as a phased item. So when we start working on the next phase of items, which would include the tiering concept, we will include this particular ask as well. The other user story that was brought up was that we would also want the ability to set two fields in ingress rules and from fields in the egress rules. So if you look at Kubernetes network policy today, it just has an ingress section and an egress section. The ingress section will talk about the traffic incoming to the applied to pods. And so in that case, the two is always the applied to set of pods. But I think Ranjan had a use case where he maybe something for outside of the cluster. You may have VMs or nodes which have multiple interfaces, and you will apply the policies on those interfaces or those nodes or VMs. But you may want to only select a subset of those interfaces that are associated with that node. So you might apply the policies on the node, which has all the interfaces, but then in the to section, you want to granularly select only certain IP addresses to be allowed. So in order to accommodate that particular use case, there were a couple of approaches available. One was we collapse the ingress section and egress section into a very generic rule section, which will have two from direction in it. But that would be a little too far away from the Kubernetes network policies and might add to a learning curve for users. So we decided to do a compromise as to still have the from and still have the ingress and egress sections in the policies, but also generalize they will refer to the same structure internally. So in the first phase, we will, let me see if I can share the screen. So in the first phase, we can, it's not loading. There you go. So instead of, earlier, as you can see, the ingress and egress were pointing towards, an ingress rule struct or and an egress rule struct, which would have the corresponding fields in it. We decided to still have the ingress and egress sections for the policy spec, but they all map to the same struct here, which would be something like this, which would have the from and to. In the first phase, we will only allow setting to in egress rules and from in ingress rules. But as and when we have add more support, we'll relax those validations, and we'll allow people to set to's for ingress and froms for egress. So that led to the change of the structure. So I've changed my PRs to reflect this as well. So these were, and there was another kind of a comment that came was like, we should also have an ability to set applied to on the rule basis, which would override the entire policies applied to. But we haven't found real use cases or something that or good user way or UX for this particular field yet. So it is something that can be incrementally added, when we move forward. But that has been put on the back burner for now. So those were the major items that were discussed and updated the doc since then. And I think yeah, that's about it. And I'll just go through the phased. I mentioned that we'll do this in like a couple of implementations. So the initial phase will target to have like a cluster network policy on the cluster scope basis, which will allow network administrators to create these security policies using the label selectors. That will be that's how we'll apply policies, using label selectors, not yet via matching names. That would come in the next phase. We'll still limit to pod selectors, namespace selectors in the first phase for the to and froms and the applied to. And we will provide the ability to prioritize a particular cluster network policy with respect to the other with the priority field. So the user can set those priority fields, and then we can have like an order within a tier. Later on, it will be reflected within a tier. You can have like specific orders, and then you can have ordering between tiers as well. So you can have like a hierarchy. So that will come in the phase one, next phase. Then we will also, the rules that you create in the network, in the cluster policy, they will be ordered. So the rules that are created at top will have the higher priority. So will be evaluated in stress. We will also target the actions of allow and drop. And I think in the next phase, I always wanted to ask. In the next phase, we'll add like reject action, which would give some feedback to the client, and a pass action to jump to a different tier or a different policy. So that will be a follow-up. And then also allow IP blocks in the policy. So this is like the first phase, and then we'll add the categories. We'll add the ability to set to in ingress and from in egress. Then using match the workloads directly using names. Then we'll do logging per rule and support more actions. And then we'll also support more workloads. For example, external entities for the nodes and other entities outside of the cluster. Nodes specifically. Then we'll think about services and DNS-based selectors. So these were the changes, and for this particular item, there are two controller side PRs up for review, and the agent side work is also in progress. So that's the status. I also, after the status, if there's any question on this, please go ahead. After the status, I had another kind of a proposal for the naming of the sub resources of the API groups, because it's, if we start like have a formalized way of naming these things for the new CRDs that are coming in for Antrea, I think there are a lot of in progress work. So if you have like a standardized way of doing this, it will be nice. I had like a one proposal. So if there's no specific questions on the cluster network policy, then I can talk about that proposal.
I do have a question.
Mm-hmm.
So regarding, I think it was the first no, the second item you mentioned, which was from field added to egress roles and the to field added to ingress roles.
Mm-hmm.
Can you clarify if there is any case in which this makes sense for what we support today in terms of like the applied to field? Because today the applied to field is going to select like pods, correct? And so if I define like an egress role and I want to set a from field, what is that from field going to look like? Because concretely, because we basically right now have a single interface per pod.
Yeah. So so that for in cluster workloads, it probably doesn't really make sense. So that's why we didn't add that in the first phase itself. I think it makes more sense when you have like when you're applying policies to something like nodes or external entities, something which is outside of the cluster, then it might make more sense. Another use case that I can think of is maybe a pod with multiple interfaces, with whereas you're applying the policies to the pod, but you might have like secondary interfaces in a certain IP block, and then you just want to specify traffic to just apply to those IPs. Maybe that's a use case in terms of pods.
And since the syntax for from and to is basically the same, whether it's an ingress role or an egress role, that means I can do some selection based on labels. So yeah, but also I guess in terms of IP block. So basically just to confirm, today with what we have for in-cluster network policies, we would always expect those new fields to be empty, or would there be a case where it's sensical for those fields, those new fields not to be empty and for which we would not return an error?
As part of the CRD creation, in the first step, we will ensure that there is validation on the schema level, that whenever a user creates an YAML with an ingress rule and sets a to field, that will be considered as an invalid cluster network policy to begin with, until we add that support, or until we are like ready to formalize these new use cases. So we will only relax that validation when we support these cases. So users should not be able to input that via the YAML.
Okay, thanks.
Okay, so if there's no other question, I had like a, so if you see that we are creating a lot of CRDs and there are a lot of other proposals which are coming in, and most of those, most of the CRDs have like are either just randomly creating some subgroup, or a group for each subgroup for a particular CRD, and depending on what CRD it is, there is no like formal like way of like specifying like what should be, which CRD should go in which subgroup. So I thought maybe we should like formalize that, and I mean this is like an open question for the team. How should we manage that? I'm just talking about the subgroup. I'm not talking about the API, the entire API grouping. That's probably another discussion. But for the subgroup, what I was proposing is that any security related, like cluster policies or like namespace network policies, anything that is related to network policies like tiers and all those CIDs, maybe we can subgroup them under the security group. Similarly, like we have a lot of monitoring and system related information. Perhaps we can like have like a defined schema, like we put them in the system subgroup, and then any tools that we are proposing, like we have like Traceflow or something like that, there are a lot of proposals on GitHub. The tools can be put into a troubleshoot CRD, sorry, subgroup. And then if we come, if in future we talk about like doing an IPAM within Antrea, we could think of like any of those, IP pool or IP block CRDs that we might introduce. They can probably go in a network subgroup instead of like every CID having their own subgroup. So I just thought maybe we can open up a discussion around this. Maybe not today, but maybe perhaps over some other meeting, but it's something that we should think about. I don't know if you guys have any opinion on that.
Yeah, Pia, I'm just thinking, actually the only secret features we know so far are just like policy.
Yeah, so but there would be multiple CIDs associated with network policies, right? For example, you might have external entities, or you might have the tier concept, which is a CID, and then there would be namespaced network policies, which would fall in this category.
Well, maybe I should ask you, do you think any other, potentially any other policies also fall into security category besides that policy?
You mean beside the cluster scope policies and the namespace scope Antrea policy?
Right.
At the moment, no, but there could be other resources related to these, which would be considered as CRDs. Maybe we could add that. I'm not fixated on the names. I'm just fixated on the fact that maybe we should have like some subgroup.
Okay.
Which defines, like, security is not something that I'm proposing. Like, it has to be security. It could be anything. But
okay. So basically, the question is, should we have small groups for that policy, for example?
Yeah. Which includes like network policies and grouping concept. Or do we want to do like a, slice it up even further and like
going to change our API group for the controller to agent message too. Now we'll just have a single networking group for that policy and the other messages.
Yeah, I think they definitely should be kept separated. They also create problems while generating code. But I think that definitely needs to be separate, like the ones which are not user facing, the ones which are mainly used for internal purposes, like for agent. I think they should definitely be part of like maybe the networking, which we already have.
Yeah.
The only reason I bring this up is because we have some PRs in review. If we can have like a standard now, then it will be easier for like future releases. We don't have to worry about upgrades and cleanups.
Yeah.
I think there are also like some trace flows and bundle APIs which are being introduced. So they might also need to have, we might have to think about proper way of grouping these.
Yeah, I also hope to learn others' opinions. I'm not sure, maybe let's give people some time to think about this. Maybe last time we can look at some proposals.
Yeah, sure. Right. That's all from me, from my side. Is there any more questions on that, on either of the topics? If not, then maybe we can move on. Salvatore.
I'm just giving everyone 10 seconds to see if they have any additional question. All right, it appears we can move to the next topic where Srikar will talk about flow exporter design. Srikar, please go ahead.
Sure, Salvatore. Let me share my screen. Hope everyone can see my screen. Yeah. And then I hope everyone can access the link as well in the proposal. Let me know if you have any issues, and I'll change the access settings. So thanks for the opportunity to speak about this proposal today. Like I'm going to talk about the flow exporter in Antrea agent, and the main objective is to achieve network visibility in a Kubernetes cluster. This essentially useful for various things like network management, troubleshooting, compliance of network policies, etc. And the existing CNI solutions like Calico, Cilium has some sort of network visibility solutions. Calico has only the solution only in its enterprise version, and Cilium has a project called open source project called Hubble, which provides visibility into flows and stuff. So essentially, there are various things that we can answer with this, through network visibility. And then, as I listed, what are the network policies employed between two services or between two pods that are there in the Kubernetes cluster, and then which service port, L4 port, has the highest traffic on a node, and then what nodes are communicating, what is the bandwidth between two nodes in a Kubernetes cluster, and how many connections are there with only TCP send, packet send, like we can detect TCP send floods, etc. So various questions can be answered through this network visibility solution. And then the network flows are in each node at the building blocks to provide this network visibility. So this proposal is going to discuss that, what network flows we are going to collect, and how are we going to export, and how are we going to visualize. These are the things that I'm going to discuss. So as I said, the flow visibility and like the user stories that I have written to explain the use cases for this feature. One is flow visibility. I think I already mentioned flows between two pods, pod namespaces, throughputs, and then hotspots, which nodes are talking to each other the most, which pods are communicating with each other the most, and those are the things that we can see through UI. And then we can also expose flow metrics. As the flows are collected, we are going to process the flow metrics and then export them through Prometheus exporter. And these flow metrics can be of different types. They can be like number of connections per pod, number of connections per node. This can be packets, bytes as well instead of connections. And then again, the metrics, the service cluster IP L4 proto plus destination ports. How is the traffic distributed across these different ports in a node? They are the examples. And similarly, the TCP, based on TCP connection state, we can have some metrics. And then based on network policy information in the flows, we can have some metrics. So these are the use cases that I came up with. If anyone thinks of other use cases, please feel free to suggest to build upon that. Yeah. So now I'm going to go into the design of the solution. What we are proposing, the flow exporter essentially will be running as part of Antrea agent, and it's going to collect the flows from contract module. I'm going to discuss the alternatives that we looked at for our contract modules and why we have picked contract modules a little bit later. but we have decided to go with the contract flows. So the flow exporter polls the contract module and get the flows, and then this flow exporter makes IPFix flow records and also process the flow metrics as after every poll. So the IPFix flow records will be sent to a flow collector, and then there'll be a flow visualizer as well. This we are recommending Elasticflow, which is an open source solution and very popular in the community. A lot of people are using that. And then it supports IPFix protocol. So the flow exporter exports these flow records to this flow collector, and then the metrics that we are going to process after every poll will be exposed through Prometheus exporter. And then there are different ways to consume. One of the ways is Prometheus server to see the Prometheus metrics. So that is the high level design that we have. If there are any questions, I can answer now, or I can move forward.
So we can have a question here.
Yeah,
So
sure.
I think in your original design doc, I remember you consider option to run flow exporter to be a separate container, separate process.
Yeah.
Could I know the reasoning we didn't go that way and choose to put the flow exporter inside agent?
It's just for simplicity's sake as a first step. When we think that there is some resource consumption issues, as it will be polling the contract module, right, constantly. So if there are issues with the resource consumption, then we have to separate it out either as its own container or its own pod with a separate interface.
Okay, got it.
So the network, if there are no more questions, I'll move forward to the.
I have a question.
Yeah, sure.
Oh, okay. Yeah, may I speak first? Sorry. In the graph, I didn't see how it can specify which flows to export. Is there an interface for it to trigger the flow export?
Which graph are you talking about?
Yeah. So, for example, I want to set some criteria to which flows I'm interested. So maybe is there any way, or is exporting all the flows?
So currently we are exporting only the Antrea related flows, pod to pod flows. Service to service flows as well, but going through the Antrea created OVS bridge. So we are not going to export like the other flows in the system. That is the first thing. But I see that if there is any filtering, you want to see only the flows from certain pod. Is that the question?
Yeah.
So we do not have that, but it can be integrated. In the contract module, when we are going to poll, we can give a match, flow match, and then we can give certain parameters so that we can get only the flows from certain pod.
Okay.
By giving the IP, it can be extended, but currently we are going with showing all the flows going through the OVS bridge created by Antrea.
Okay, got it.
Got a question for you. Did you do any assessment of the scale impact of this design? Like, what would be the impact on the node of having the additional stuff, and how it would impact Prometheus having a whole lot of other metrics from a whole lot of other nodes?
Sure. We don't have any benchmarks as such. We don't have as part of the proposal, we want to do benchmark in the end by having some sort of setup where creating some 100K flows or very large number of flows and see how the system is reacting. And yeah, so that is the plan, but we don't have any thoughts on how it will look. And yeah, the plan is to get this functionality in and then do some scale testing, benchmarking.
I apologize, I got dropped on my last question. I didn't know if you had a chance to answer that. Or if you,
okay.
I had the question on the multi-tenancy, but then as soon as I asked it, my internet connection dropped.
Oh, sorry, I didn't get the question. Can you repeat it, please?
Yeah, I think you
We
have
did not hear it at all.
Yeah.
Okay, well, I'll try again then. I was asking if we're exporting all the flows, how will we restrict or constrain which users can see which flows? Do we want any user to be able to see any flow?
So we are going to have this Kubernetes information like pod name and pod namespace in the flow records for every flow. And then in the flow visualization, we can have filters to filter out the flows between certain pod namespaces or certain pods and certain services.
So is access to the raw flow data is an admin level type access that we actually do the RBAC control at a different component or only at the visualization? Is that what you're suggesting?
Yeah, only at the visualization. We'll have all the information as part of flow record as fields in the IPFix flow record.
Okay,
and then
so to clarify, my question is not about what information we have, but rather who can access that information.
Oh, okay. I haven't, to be honest, I haven't thought about it in terms of like levels of access.
Okay.
But I'll keep a note of what should be the solution there, and I'll follow up on that. Yeah.
Okay. Cool.
Okay, thanks.
I have a question here. Hello, can I have a question here?
Yeah, sure. Go ahead.
Okay. So do you have a plan to like get the metrics from the kernel module, like obvious DP control to get flows?
We are going to get the contract flows and then get metrics out of those processed flows.
Okay, so because
I think you're asking in terms of like interface metrics of different interfaces on OBS Bridge. Is that?
Yeah, that's one of that. And also, actually, we saw the performance issue when we deploy OBS on customers, and we see a lot of like mismatch, like a lot of packets are punted from the data plane to control process. If we see like this kind of information, so that'd be great, I think, to troubleshoot performance issue.
Oh, okay, sure. Yeah, if since those are not flow metrics as such, it's like a switch metric. So there are different kind of metrics, but we need to export them. In this proposal, we are focusing on flows and corresponding metrics. That is, those come in different class, right? So I think, one example is Antrea agent metrics, right? So we can expose that to them. Yeah, if it's possible. Yeah.
Zrikar, I don't really have a question, but I'm going to ask a dumb question just for the benefit of the meeting. It might be worth reminding, since we have quite a few people on the call, it might be worth reminding why we chose the contract module over other solutions.
Yeah, I'm going to talk about it now. Yeah, that is the next section. Yeah. So. So as Salvador pointed out, why we are going with contract flows, right? So the thing is, the contract flows give some benefits, such as it provides flow state in reverse direction. And also before going there, I'll mention what are the other possibilities. Other possibilities are OVS IPFix. There is an IPFix feature on OVS switch. directly, which can provide one direction flows information from the data plane. And then it can create flow records. There is an inbuilt exporter, and then we just have to configure that with a collector. It's used, but the problems are it cannot provide visibility into the reverse direction, and then it cannot provide connection state, TCP connection state, such as and also sometimes retransmissions, etc. And then another information that would be missing is network policy related, which contract can provide. So and then similarly, OVS S-flow, there is another flow information solution possible. S-flow is somewhat different from IPFix. What it does is it samples a packet out of many packets, and then it will send it to a collector, and then the collector will parse through the packet and create flow records for each flow. So the mechanism is different, and there as well, the cons are it will be single direction, and then we cannot get network policy information, and those are the main cons. With S-flow, there is a benefit where we can parse till L7 layer. This could be useful for some HTTP related statistics, but that we will be missing. But we have to think about if it is required, we could enhance in different ways in future. But these are the solutions. Again, going over the benefits, I went over like the another benefit I missed is if we have some kind of sampling in OVS IPFix, there we have to sacrifice accuracy. We cannot collect all flows, and then if there is no sampling, there will be overhead in the data. So that is also major thing. Whereas contract flows, we are just going to poll the contract modules. Information is there. There is no relation to the data plane. This not being implemented in data plane. So there is no overhead in data plane. Those are the points. And another point is with contract flows, we can use different kind of communication channels. We preferred IPFix communication channel because it's popular and a lot of collectors support it. But we can go for any other communication channel. Yeah, these are the benefits. That's why we went with the contract flows.
Do we have flows that won't have connection tracking that we might need to track?
Okay. I mean, I'm not able to think. I think network policies are kind of I thought in Antrea network policy is like a very basic feature, right? So I'm expecting.
I would say
are
that
there any use cases? Yeah.
At the moment, I would say that we commit all the connections to contract, so we should basically track everything.
Okay.
Okay. Yeah. Okay.
May I ask
Are
a
there any
question?
questions? Yeah, sure.
So using contract flows, it's just exporting the metadata and the statistics. But using other techniques, they can export the actual, might be packets. Maybe these are different too.
Like I think the IPFix also does the same thing. It also exports only the metadata, some fields, creates a field. But S-flow, as you said, it can get a packet and pass through it and can get a little more information. So that we are missing out. So we have to, if at all we want this L7 related information, we have to enhance in the future in some ways. But I haven't, it's kind of beyond the scope of this document, so I left it there. So, but we are focusing till L4 visibility and providing the metrics and yeah, as part of this flow export.
Okay, thanks.
And Srikar, two simple questions from me. I seem to recall that the flows that we are exporting, we are just exporting like the raw contract flow. So there is no, there isn't anything in the data that we are exporting that will allow let's say, to link back a flow to a particular couple of pods or to a particular connection between a pod and a service and so on, right?
We are
Apart from
going
the
to
API addresses.
we are
Okay,
going
good.
to actually export that Kubernetes information. Yeah, I'm going to talk about it.
Okay.
Given IPs, we are going to correlate with the pod namespaces, and then
Okay, so
service
I
names.
mean,
Yeah.
if you're going to talk about it, I'll shut up now.
Okay, sure. I mean, yeah, like there are some plans, but in the first phase, we are not going to have everything, but I'll go into details in a bit.
Okay.
Yeah. Yeah. Okay. Yeah, if I can continue now, I'll go through the features that the flow exporter will have. I like the as mentioned before, flow exporter will run as part of Antrea agent container, and then all the configuration options such as enabling the flow exporter or providing the collector information like IP and port are provided through config map, and flow exporter will poll the contract flows periodically, and then we'll keep them in a connection map and kind of aggregating those flows. And we create only flow records after some time, like say 5 to 10 minutes instead of in seconds, and then send the flow records rather than sending them as soon as we're polling. We poll the contract module. So that is the high level idea. And yeah, as Jianjun brought up, there could be some issues with the resource consumption, and we have to move to a different container or a different pod future. So now I'll go through the flow record, for example. How will it look like? So there are like the basic fields we are going to expose are like the flow, like octet delta count, how many bytes that we have seen before the last export compared to the previous export, and then packet delta count, and then the flow start seconds, flow end seconds, the source address, destination address, L4 port information, proto, and then we are going to create new fields which will have a different enterprise ID, the Antrea specific, the source pod namespace, source pod name, destination pod namespace, destination pod name, and then there are certain reverse fields to get, since we have bidirectional flow information in contract flows, we are going to get that field information as well. So these will be there, and for every flow, we are going to create a record with these fields and going to export on using IPFix protocol. So that is the idea, and then there is one public library that we can use to export the IPFix flow records, but that library is kind of old and it's not maintained. Well, like I haven't seen any recent check-ins. So, and then it also doesn't serve the purpose of like there is a use case in our proposal where we have to intercept IPFix flow records and add new fields in each flow, and then again send it to collector. We are kind of calling it as IPFix forwarder. That feature is not there in the library. So we decided to write our own library, IPFix library, and use for flow exporter in Antrea agent. So that's another detail that is there. So
Can I ask a quick question?
Yeah, sure.
Have you thought about anything around compression in terms of flows that are repeated all the time? Is there some way that we can add a field that basically says we've seen this flow 100 times instead of exporting that flow 100 times, depending on your collection period? I'm not sure how IPFix works, but I'm just curious if there's ways to compress the data.
So the flows are essentially like 5 tuple flows. So we'll be like updating the flow information for each 5 tuple flow in every flow record.
Okay.
Like yeah, so yeah, essentially, let's say the flow is there for 10 minutes, and we are sending flow records every 2 minutes. So we are going to send the number of packets like every 2 minutes, number of bytes, and then we are going to update the flow record. In the next flow record, we are going to send it for next 2 minutes. So that's how it's.
So what are those 5 tuples?
5 tuples are IP, source IP, destination IP, L4 ports, and then protocol.
Stephen, the network 5 tuple is a standard term for connections, right?
Yeah,
okay,
so
I got it.
A network 5 tuple. Yeah.
The reason I was asking is, while this is going on, I'm looking over at the Calico specs, and I see them. I found a document that talks about 5 tuples on their flow logs. So I was wondering if it was the same concept as that. And their 5 tuples are source namespace, source pod, source labels, which is interesting because I haven't heard us mention labels. And same things on destination. And they log the policy.
Oh, okay.
It's the same thing.
Okay.
Yeah, it's kind of same. Yeah, the IPs will be mapped to pod names, right? Pod namespace. So.
And on the labels, is the proposal going to capture those too?
The pod label selector, right? I think I haven't thought of using labels, but
I see the Calico gives an example of environment equals dev versus production.
Okay. I'll make a note of that. And also
I could see that being useful if you've got a large environment to sort, out of different classes of workloads.
Okay, sure. Can you share me the link offline? Or
sure, I'll put it in the chat right now.
Yeah, sure. Okay.
Thank you. Hey, Srikar, you said something about a 2-minute window, but the frequency at which we're going to pull contract is going to be smaller than this, right?
Yeah. Okay. So we are going to poll it frequently, but we are going to send flow records every 2 minutes. Yeah.
And you wrote like 5 to 10 minutes in the document. When you say 2 minutes, you mean like?
Yeah, I meant in minutes.
But it's going to be configurable, right? Is what?
Yeah, it's going to be configurable.
Oh, I see the 2 values now. Yeah, 5 seconds.
Yeah.
5 minutes. Okay, thanks.
Yeah.
Can I revisit the compression thing just one more time?
Yeah, sure.
The reason I was asking is, say you have a lot of quick flows, right, that open up a HTTP connection to do a quick get, right, and close down, and they always look the same in terms of source and destination. Right. The reason we might want to compress that is if it's always the same thing and it's generating a lot of data from an enterprise use case perspective. There a lot of times logging is going to be priced by amount of throughput, right? And so if it's not generating any additional information, but we can compress that down, that would be really useful for saving costs from a logging perspective for enterprises.
Yeah, I can see. I mean, you are saying that we can aggregate like individual flows into a bigger bucket, like
it's something that we could probably. Yeah, we could probably have a configuration option that says whether or not we want to turn on flow aggregation of some sort.
Okay,
Cody, it's a bit. I mean, like practically, the 5 tuple would be different though, because the source port would be different. So it wouldn't really be the same flow. So we may want to keep track of this, and we may actually want to keep track of the total number of flows.
Agreed.
Yeah.
Right. The 5 tuples, you're right, would not be different. The question that I think I'm trying to
would be different.
Yeah, they would be different. The question I'm getting at is if the source on the egress side and the destination, I mean the what am I getting at here? The source on the egress side, right, in terms of port, right, that could be changing, for example, and cause the whole 5 tuple to change on every send. But we may not necessarily, from a practical standpoint, have more information, right? For somebody who's actually interested in understanding the service graph or looking at the flows from a service graph perspective, somebody may need that detailed information. Some monitor may not need that. So I just want us to explore the idea of if there's ways to compress that data.
In the proposal, we also support the bytes and the packets number, right? If you want to increase information, you cannot compress in the way you described.
Yeah, but it's an interesting question to know if we're going to be able to compress with the IPFix format, which I guess is what Janjun is saying. It's
yeah, I'm just proposing that as a Kubernetes clusters are generating lots of logs, right? And so at points in time we may want to see if we can lower the noise floor.
Yeah,
that can be done at a higher level, which is, I mean, assuming we don't generate, I mean, we may generate like a lot of IPFix data, but that doesn't have to be like exposed in a raw fashion directly to the user, right? We can, assuming we don't generate too much traffic, we can do that compression and remove that noise at the collector level if we write like a custom collector.
Right.
Okay.
Yeah, if I can add something, we can actually expose that through flow metrics as well, like some sort of aggregation, like across all the flows, not exactly through flow visibility, but these like L4 port, right, based on service, the flows number of packets that are seen as a metric at the aggregator, like by aggregating all the flows and create a metric. And then maybe user can configure the metrics that they want to see, right? Instead of the flow visible, like seeing as part of the flows, we can expose them as different metrics, the aggregation.
Got it.
Right.
But I mean, it's still an interesting question from the point of view of, is there a case for some like traffic patterns where we're going to generate like an unreasonable amount of data, which is just going to use too much bandwidth and put too much load on the cluster or the aggregator or the collector? I think it's kind of related to Kobe's question about benchmark. I think when we benchmark, we kind of want to test that scenario that Kobe is describing, where we have a very large amount of small RPCs, small connections.
Yeah, I can see that. Yeah, maybe sending only one IPFix flow record for all the flows, like by keeping certain fields empty. Is that like because we are going to compress the source IPs into one flow,
yeah,
right?
Or maybe we can have like thresholds. I mean, if a connection is less than, I don't know, 250 bytes, like just don't include it. I don't know what's reasonable.
Right. Yeah, sure. I'll keep a note of that. Yeah.
I guess one example could be that if someone is doing a malicious client is doing a port scanning, and we can see if this is causing a lot of unnecessary traffic, or if this is something to be detected, would that cause the?
Well, I think we would only include connections which are in an established state potentially. In which case, if you're just doing like port scanning and you're just sending like scene packets and waiting to see if you get a NAC or not, I'm thinking if this is the case where you're describing, then maybe this wouldn't be too much of an issue, assuming we only send like information about established connections, and separately we can keep track of, as Srikar described, actually, those connections that have a scene packet, but the connection is actually never fully established.
Like as a flow metric, right? Like number of flows that we have seen only with the SYN packet.
Yeah, as a metric. Yeah.
Rather than sending it as an IPFix flow record, we can. Okay.
Yeah.
Yeah, that's one way. But yeah. these are good points. I'll keep a note on the aggregation. I think, some other solutions also try to aggregate across only the destination port, like port 80, which is useful. So they don't worry about other things. So there is there are some solutions out there, but it's a good point. I'll keep it. Yeah. Okay. Moving forward, I think I have only 5 minutes left. We are going to, as a first step, we are going to add some local Kubernetes resource information at agent. We are not going to add everything. Like, for example, in a flow, we may not know, we may only know the source IP or destination IP, like the pods corresponding to source IP or destination IP that is locally available. We are going to add that, but we are not going to add the remote pod name and remote pod namespace. That is the first thing. And then we are going to add some network policy information, like network policy UUID, network policy names for each flow that will be there. And then there could be cluster IP. So in a flow, to figure out which service the flow is going to. So I'm considering that as a future work. We'll focus on first these two things, and the cluster IP information in each flow. We have to keep track of that to get the service mapping between flows in the flows. Yeah. So, and then the flow metrics, I think we talked about this quite a bit. I'm going to skip this, and then the connection map. Here we are going to maintain a connection map. My initial idea is to have flush this connection map after we export to the IPFix collector, and then have like after new pole, we are going to fill up the connection map and aggregate for multiple poles. And then, Antonin brought up a point where it could be useful to keep the connection map. So there could be use cases, but I did not see any yet. But if at all we have to go with an alternative, we can basically only flush the connections when we don't see the connections in the new pole outputs. If we don't see the flows, we can flush it rather than flushing after every export to the IPFix character. So that is the idea here. And then everything is in memory storage with the connection map.
Is this connection map using a lot of memory that you feel the need for flushing it?
Yeah, it may, because depending on how many flows that are there in contract, how many pods in each node, and then
all right.
Yeah, so it may get scalability issues can come into it.
All right.
It's bounded by the size of the contract table, right?
Right. Yeah. So and then before I think you're going to discuss this part, integration with Elasticflow. Don't know if you can go over the time. Is that okay, Salvatore?
I mean, technically we have only 20 seconds left. So I mean, if you can handle it in like in a few minutes, that's okay. If it's only taking a few minutes, I guess it's okay. It's just, I have no problem with the meeting lasting more than anticipated. It's just that it's kind of late, especially for the people in the United States. So if we can sort it out in a few minutes, it's okay.
Io, can you Io worked on this part, so can you?
Yes, I can have a very quick overview of the Elasticflow. So our visualization solution for this flow visibility and matrix is Elasticflow is built on the Elastic Stack. It includes the bits to collect data, the Logstash to process and aggregate data, and send it to the Elasticsearch, which can work as a database, and Kibana will visualize all the data in their dashboard. And For the IPFix flow records, we will use Firebase to collect data and do some customization, such as add some IPFix fields for Antrea and the Kibana dashboard has their pre-built dashboard for the flow records. We have a POC for that. As you can see that we have some the Sankey diagram can show the throughput from port to port, and the port name and port namespaces can be shown in this diagram. For the flow matrices, the metric bit with Prometheus module can be integrated to our project to collect data from the Prometheus so that we can show our matrix data in the Kibana too. So that is basically what the visualization work. Yeah.
And I see the visualization is not a core component, but it allows us to at least demonstrate what we're collecting. The question I have though is about scaling. Like, how does this visualization scale as the model grows? I mean, sorry, not the model. The number of pods grow and the number of connections grow.
We can set some filters to filter it according to a range of time, or filter it using the namespace, so it will show less and more clear records.
Okay.
Yeah. And then quickly, the future work or imminent work we are planning to add more the rest of the Kubernetes information at some kind of a central aggregator, where every agent is going to send the IPFix flow records to this IPFix aggregator flow forwarder, where we are going to intercept the flow records and add the remote pod namespace, service names, etc. And then we are going to send it to the flow collector. So this is the next phase or next thing that we'll be working on, and then we can actually expose the flow logs to and control as well. Yeah. This is what I have to do. Yeah. If any more questions?
Srikar,
yeah.
I have a quick question. So if we want to integrate with PACE, is there some extra work to be done for that?
Vicky, probably we should not talk about this specific thing here. I mean, since we are close to the end of the meeting, probably let's do offline, I guess.
Okay.
Yes, we can defer this kind of discussions to the appropriate threads. And is there any final question concerning the contribution that's being proposed in this document? Okay, so it seems like we are at the end of the meeting, so I'm going to stop the recording now. And so, by the way, is Ricard, in terms of being able to deliver a POC for a demo, do you already have a tentative timeline for this?
Yeah, we are thinking of, I mean, we are working on IPFix library, which is kind of, we are writing it from scratch. So that is one thing where we are not sure about the timeline. So we are currently, the work is in progress. I think, but we are actually trying to push it into the release, instead of doing a POC. I don't know the format. We are trying to push checking the code into the master.
Sorry, it is okay. I didn't mean you have to do first a POC before pushing the code in the master. I think as soon as the development branch has something that you can show us, I was thinking if we could have a demo too.
Okay, sure. Yeah, I think we are targeting certain things, but you know, there are currently it's in progress, but we don't have any like
Okay.
I think confirmed timeline. Yeah.
Okay, so I mean, I don't want to ask any more questions because we are really over time now. So I'm going to stop the recording. Thank you very much for presenting this demo. And thanks everyone for attending. And we'll meet again in 2 weeks' time. If you will have, if you think you have something nice to present, or is there anything that you'd like to discuss in the community meeting, please don't forget to propose your topic either on the mailing list or on the Slack channel in the Kubernetes space. Thanks everyone for attending again, and have a good one.